So problem 28.15. It says, a wire carrying a 28 amp current bends through a right angle. Consider two 2 mm segments of wire, each 3 cm from the bend. Find the magnitude and direction of the magnetic field these two segments produce at point P, which is the midway between them. So we have in the picture on the book, we have two segments like this. They're the same distance, and then they have two segments, one right here and one right here. They're in the same spot, and then they're 3 cm from here to the end of the edge over here. 3 cm. So 3 cm. 3 cm. 3 cm. And then the current is going this way, and then the point P is right here. Let's write a little more over here. We're supposed to be is at the middle between them two. Okay. So the segment length is 2.0 millimeters, and the segment over here is the same thing. So it's saying find the magnitude and direction of the magnetic field these two segments produce at point P. So it didn't say any long wire, so we're just gonna do dB since it didn't say that it was long. So the formula is mu sub naught over 4 pi times current times dl times sine of theta or phi, whatever, over r squared. And we know what mu sub naught stands for. Mu sub naught is 4 pi over 4 pi times 10 to the negative 7 Tesla meters per amp. And we divide over 4 pi. So that's that. And then this is times the current, which is, let me see if it was given. Yeah, it's 28 amps. In the textbook, the current was 28 amps. So it's 28 amps. And then the DL is the segment length. So in this case, it was 2 millimeters. Let's convert that. Yeah, 2 millimeters. 2 meters. Okay. 0.002 meters. And then it is sine of phi, which it was the distance, the angle produced from the wire to the point. And that's this distance, just like this. Right here is the same thing. So we're trying to find this angle. What's the angle over here? And since this is a square right here, then this is half of the square. Then it's usually 45 degrees over here because it's 45 plus 45 is 90 degrees. So this is 45 degrees. So 45 degrees from the distance for the wire to the point. And then this is over r squared. And r squared is the distance from the wire to the point. And that distance, let me see. We know that in order to get the distance from the wire to the point, then first we need to find this distance and then divide it by 2. So in order to find that, it's we'll use a Pythagorean theorem. 3 squared plus 3 squared is equal to, square root is equal to the hypotenuse. And in this case it was 4.2, I believe. 4.2 centimeters. And we divided by 2 because the point is at the middle over here. So it's equal to 2.1 centimeters, and we're gonna convert to meters. So it's 0.021 meters, and that's what the radius, or this, not the radius, the distance is. Okay, and we square it, and then when we solve for everything here, then we result with 2.88 times 10 to the negative 6 teslas into the page. Okay. But I did forget something here, and it was the 2 times, because there is 2 wires right here, and they are both the same, and we are trying to find the magnitude and direction of these 2 wires. So 2 times, it will still result to this answer that I gave. So thank you.